Well, thanks for having me, Jean-Georges. Thanks for inviting me. I really appreciate it. And happy Pi Day to everyone. Uh, Too bad it's not the 24 hours of Pi Day like you intended, but I think we should still have some good conversation around this. So I'm Seth Dobrin. I'm the Global Chief AI Officer at IBM. I'm responsible for IBM's overall AI strategy, and for IBM, our strategy is a whole company and focuses on two things. It focuses on hybrid cloud, which is centered almost entirely around Red Hat OpenShift, and AI. And AI at IBM is focused on AI for business and not consumer AI. Which brings us to the topic at hand, right? We're in the midst of an AI revolution, but people are still very suspicious and in some cases fearful of AI. And in order for us to truly unleash the potential of AI, in order to reinvent our future, we need to move beyond the advancements in research technology, and we need people to trust the algorithms that impact our lives. But let me take a step back and start from here. The biological circuits of neurons help to explain a popular machine learning technique, artificial neural networks. And yes, I'm going to talk to you about machine learning, algorithms, and AI, but not from the perspective you might expect. Trust is the real driver of AI adoption, and it's crucial to begin to approach this technology from a human perspective by actually taking a step back. And the perspective changes when we look at the broader picture. And this image is an analogy from the field where I actually started my career, human genetics, specifically psychiatric genetics. And I bet you might be wondering how a human geneticist became the first ever chief AI officer in one of the world's biggest companies in the realm of AI. And in fact, I get asked this question all the time, but believe it or not, there's a lot in common between being a human geneticist and leading data and AI transformations in the enterprise, even if it doesn't seem like it. For instance, in the late 90s, at the time of my early academic career, was the time of the founding of what we know today as big data, which, if you think about it, the origins of big data come from hard sciences such as astrophysics and genomics or genetics. Additionally, back in the 90s, we were starting to use similar tools that we use today to solve math problems like R and Python, which arose during this time. And throughout my career, from human and plant genetics to academics to startups and multinational corporations, my entire career has been rooted in pushing the boundaries on the combination of advanced automation methodologies at scale, leveraging data and math, all with the aim of creating better, faster, and cheaper solutions that can solve real human problems and can be trusted by people across the organization. In fact, trust is crucial when it comes to scaling AI. Trustworthy AI and AI ethics are among the most discussed topics today, and there are many frameworks, guidelines, assessments, and regulations that are being provided. And I know what companies have to deal with, and it's very complex. And if we're honest with ourselves, at best, it's a mess. But people tend to forget that ensuring the design and development of trustworthy AI systems that are fully integrated with a company's business process requires much more than technologies to mitigate bias or address regulation. The matter is much more complex than that. Operationalizing AI at scale starts from growing and maintaining an open and diverse culture, fostering inclusiveness, a culture where AI is human-centered. It's the culture in an organization that allows it to set up proper data and AI governance that ensures the development of AI solutions that are grounded in ethical principles. The pathway to trustworthy AI is long. And again, it requires a human-centered approach that's rooted in the value of diversity, to use AI to solve humans' problems to generate real, tangible value. And I've realized with time that almost all the initiatives I led from the beginning of my career have laid the foundation for the creation of this human-centered culture I'm talking about. A culture that is essential for putting trust at the core of AI technologies and generating value for organizations. And it's through this lens of my journey in data and AI that I'm going to talk to you about how to set the basis to instill trustworthy AI technologies in an enterprise. And to be honest, making the transition from a hard science like genetics to heading the data and AI transformation is not such a big leap as it might sound. It's taking a step in a totally different direction. That's the huge challenge. And this is precisely where the perceived leap comes in. If you think about what's at the heart of data science and AI in the enterprise, it's basically applying the scientific method using math and computer science to solve business problems at scale, all with the goal of creating net new value. Ultimately, with a slight step to the side here and there, I've brought the application of the scientific method in a field very far away from genetics by completely changing industries when I joined IBM. This is how innovation happens, by putting ourselves at the intersection of different fields and making an effort to collect the dots along the way to draw a bigger picture. In my case, the picture was cross-functional, data-driven solutions that help companies to reinvent their business models. That's why one of the first initiatives I worked on at IBM was the creation of a new team, the Data Science and AI Elite Team. I designed this team as a pool of experts with deep skills in machine learning, deep learning, data engineering, data visualization, optimization research, and data journalism to help IBM and our customers successfully execute, operationalize, and scale AI in the enterprise. Through my journey, I've realized how companies invest heavily in software, hardware, and time hiring the right top talent. And yet, despite all the effort and money, many of these companies get back little to no value. And this primarily happens because they spent all these resources on too much experimentation and projects with no clear business purpose set up front, which as a result means they don't align with the organization's strategic initiatives. With the Data Science and AI Elite Team, I wanted to turn data science from being a scam into a source of value by showing enterprises how they need to consider turning their data science programs from research endeavors into integral parts of the business process. The experiment of the Data Science and AI Elite Team resulted in huge success. The team has acquired more than 110 client references and has completed more than 260 client engagements. And the way the team operates has profoundly changed, even within IBM, the mindset of how to approach data science and AI and how to use it to generate new business value. A year after the creation of the Data Science and AI Elite Team, we started another team to help accelerate AI value creation. This is a team of domain-specific chief technology officers who also have a deep expertise in a given industry sector. These industry CTOs help to tie the AI to the business outcomes to accelerate generation of value for their industry through the consumption of AI. Although the actual strength and immense success in the team truly dwells in its diversity. Now think of a menu. Do you eat everything on it? Absolutely not. You pick and choose, right? Yet this is yet another analogy to which comes from my wife, an analogy between a menu and a job description. Long before joining IBM, while working at a previous company, I was trying to find simply one good data scientist to add to my staff. One, not more than 100 as it was with the Data Science Elite Team. So not only was I having trouble finding qualified candidates, but I also realized there was zero diversity in the candidate pool. Now, tired of my frustration and complaints, my wife helped me realize that the job description I wrote contained more than 24 qualifications. To frame it in her words, it was too much of a wish list. And she was right. Most of the criteria were not necessarily skills that were required for success. She suggested reframing the job description to a short menu of desired attributes. There's what I want, and then there's what I need. For instance, I don't need someone who knows Python, R, Julia, Scala, Java, and JavaScript skills. I need someone with Python or R plus one other language. I don't need someone with an understanding of every database known to humankind. I need someone with experience in at least 3 of the following databases. I shouldn't care about the number of years of experience. What I really care about is the level of demonstrated mastery. Well, after doing that, I suddenly had twice the number of qualified interview candidates, including women, people of color, and other underrepresented groups. There's an entire body of research out there explaining why the diversity increased so much with this approach. Now, when it came time to assemble the Data Science and AI Elite Team, we adopted the same strategy to ensure it was highly diverse. With some of my then colleagues, our HR partner, our talent acquisition partner, we evaluated the entire hiring cycle, from writing the job descriptions to making the candidates an offer. The main rule we established was no conducting interviews until we had a diverse pool of qualified candidates. Again, an approach we drew confidence in from many studies and research in the field. Following these practices, we minimized bias during the hiring process and created a diverse team of highly technical and highly talented individuals from 21 different nationalities, speaking 27 different languages, of which 43% were women. And we did this not because it was and still is the right thing to do, but because diverse teams drive better business outcomes. This is proven by top academic and real-world research. There's ample evidence to suggest that diversity is good for business. A McKinsey report found that companies ranking in the top quartile for racial and ethnic diversity were 35% more likely to have financial returns above their respective national industry medians. But diversity is not just about hiring diverse talent. It also establishes forward-thinking practices and policies to nurture and preserve diversity within an organization. With this the belief, we drove a number of initiatives in IBM to support different communities and grow talents in data science. For instance, together with several female leaders, we co-founded a diversity network we named GROW, Guidance, Resource, and Outreach for Women in IBM, to advocate for women within IBM. To retain and grow talents in data science, I started leading the data science and AI profession board within IBM, where I'm the executive sponsor. And through this board, we've provided a clear career path for data scientists through a skills-based assessment and qualification program inside IBM, as well as externally through the Open Group. And also, as part of the data science and AI elite team, I started the first ever apprenticeship program in data science to give people with zero background in this discipline the opportunity to learn this high demand skills and develop a career in tech. Along with these initiatives, I also started to change the old-fashioned way of mentoring diverse communities, because mentoring is important, but it must be backed by sponsorship and advocacy. Diversity and inclusiveness spur innovation. Innovation generates concrete business results. A diverse and inclusive team is more than male-female, or black, brown, white, or differences in sexual orientation. It's also differences in backgrounds, socioeconomical, cultural, language, skills, training, cognitive processes, and so on. In fact, multidisciplinary was one of the facets of diversity and inclusion that we looked for. Prior to joining IBM, while leading the data and AI portion of our digital transformation, I remember taking part in a project about implementing a mobile experience to interact with farmers in India through an app. To everyone on the team, it sounded like a fantastic idea, and everyone was really excited about the project until after a design thinking workshop, we discovered that actually the farmers, our end users, could only use the SMS service on their phone, meaning an app was worthless. If we had pursued what we thought was a great idea without thinking of the user first, we would have wasted time, resources, and money. Approaching AI from a human-centered perspective is fundamental. We only provide tangible business value to organizations when we create solutions that solve real human problems. AI is only a means to an end. The ultimate goal is to help and augment humans. In fact, the choice I made to equip the team of data scientists with data journalists and data designers was to radically change traditional data science practices applied to business problems by rooting them in a human-centered approach. Through my journey, from scientist to business leader, I've learned several lessons. One of them is that bringing a diverse cross-section of wild ducks together with purpose creates innovation. And innovation has indeed been the objective of my entire career in an effort to bridge the gap between business, AI, and human needs. The focus on humans brought into these engagements led to the adoption of design thinking workshops in data science, which were radically innovated by adapting them to data and AI to better serve both the end user and the data scientist. In addition, the human approach revealed the importance of adequately communicating AI outcomes to the end users, which prompted the adoption of data storytelling to transform algorithms into actionable knowledge and concrete business results. Ultimately, the attention to users uncovered the need for having a well-defined data and AI strategy to craft an overarching story that helps to envision a new AI scenario and explain how these scenarios may play out. The experience of the data science and AI elite team made me realize that what I accomplished over my entire career has always been directed towards the creation of a human-centered approach for data and AI business practices. In fact, to lead a portion of my previous company's digital transformation, I created a framework I called the decision portfolio to identify the company's strategic initiatives in data and AI based on the user's needs and assess those initiatives by assigning them a business value. Yet once I joined IBM, I realized that the framework I had created couldn't really help me as it didn't scale. I needed a way to fasten the time to gather user requirements on data they needed to run the business efficiently. Also, I needed a way to make sure we developed solutions that would make a real impact. Therefore, the team started adopting the design thinking practices and reinventing them through the lens of the decision portfolio framework. We used design thinking to identify business problems from a human perspective through a data-driven approach. This was groundbreaking. We used it to identify real user problems, uncover all the critical business questions they have, and use those questions to extract the information they need. We then turn the information into the data sources that the data scientists use to design and develop solutions to solve the user's problems. By approaching digital transformation from the human needs and unknowns hidden within the business strategy, we provided the business a tool to carefully design to transform data into actionable insights, explaining the business dynamic and answering all the critical questions that the users have through trusted data at their fingertips. Through an IBM-wide effort across finance, sales, design, development, and product teams, we're able to create a management system that today is IBM's single source of truth for the business and is adopted by nearly every senior executive. This methodology completely changed the way data is used by business teams and accelerated IBM's digital transformation. Now, re-engineering the decision portfolio framework through the lens of a human-centered approach using data-centric design sparked an innovative collaboration between IBM Design and our team. The outcome of this work is today what we call IBM Enterprise Design Thinking for Data and AI. IBM Enterprise Design Thinking for Data and AI is a human-centered methodology that illuminates how to employ data and AI to build an AI strategy and an execution plan for trusted AI solutions. By bridging the gap between the strategy and the execution, this framework enables teams to design and build solutions that provide concrete business value to their organization while solving human-centric problems, putting up front who will be using the data or the AI, how they will be using it, and what they will be using it for, and why it's even needed in the first place. With this framework, which is divided into a strategy session and a technical session, teams transfer business intents into concrete actions. In addition, by the use of specific AI ethics and AI explainability activities, this methodology enables the design of an AI strategy that puts trust at the core of every solution that is ultimately implemented and operationalized in the company's business. In fact, this is one of the missions as IBM's first ever chief AI officer, helping companies design an AI strategy that aligns with their business needs and puts trust at the core. Once companies achieve a mature digital transformation, it's time to focus on strategy to industrialize the data and AI and analytics to enable AI to reinvent the core of the modern enterprise. Trust is vital in this process. And we started the journey right from here, from this image about the 3 pillars of trustworthy AI. But as you've probably gathered at this point, trustworthy AI is the result of different integrated processes, tools, and technology that cross the cultural fabric of an organization. The level of maturity achieved by enterprises in the realm of AI with the operationalization of AI models has prompted the need to trust in AI's outcome. And this is possible by creating a data and AI governance framework through which we monitor the entire AI lifecycle, ensuring that models are compliant with AI ethics principles. And for us at IBM, these principles are transparency, meaning AI needs to be easily inspected, explainability, because people are entitled to understand how an AI arrived at a conclusion, fairness, because AI should always help people make better and fairer choices, robustness, AI needs to handle exceptional conditions effectively and minimize security risks. And finally, AI should preserve privacy because AI solutions must preserve the privacy and security of users' data. Now, these 5 principles guide the development of trust and responsible business outcomes, driving more value for companies by making them more profitable, more efficient, and more secure. In fact, companies cannot generate business value through AI unless they can trust the outcome of their AI systems. Think about the recommendations we get or the information we provide to our customers by employing AI. If AI is not trustworthy, the link between the business strategy and the AI strategy will inevitably break. Because of the urgent need for companies to define what trustworthy AI represents to their organizations and integrate that knowledge into the actual business operations, we started an IBM-wide effort around creating a trustworthy AI set of solutions. Through these solutions, we help customers deliver trustworthy AI systems and put AI ethics principles into practice through an execution model focusing on 4 different areas, reflecting the different needs of organizations today. These areas encompass a mix of tools and technologies, as well as expertise of services organizations that help customers to deliver AI governance frameworks by building with them from scratch the conditions to develop trustworthy AI systems. The monitoring of full AI lifecycle, where we partner with customers to plan, build, deploy, and manage new AI solutions, all while ensuring trustworthiness of AI. The ability to assess, audit, and mitigate risk, meaning we offer guidance and tools to help customers and build solutions to assess, audit, and mitigate risk for their existing AI capabilities. And ultimately, we also help with education and guidance by providing best practices for building trustworthy AI solutions for data scientists, developers, and decision makers, and also through standard courses and certifications. Now, this was quite a journey, but it doesn't have to end with this talk. Actually, I hope this is only the beginning of a new conversation. Now, there's still a lot to do to make AI responsible and fair, and that's why it's critical that experts in this domain make sure to focus their work on changing the narrative around AI by putting a genuine effort into creating trustworthy AI solutions that can truly empower human beings and help us reimagine a better and fairer future. Thank you.
Well, thank you so much, Seth. This was pretty great. This is a thing with virtual things. I'm pretty sure people are clapping behind the screen on mute, which serves no purpose. So anyway, so we've got a bunch of questions. Okay, yeah, people are finally getting, yes, you can virtually clap too. Okay, Zoom allows that. And you can see all the comments. Ralph, you got a few questions here. Can you start firing the questions?
Thanks for asking me. Yeah, it's so great, Seth, to have you on this talk, and I really appreciate to ask you. The first thing, you talked a lot about AI, where we are, and you are certainly the most knowledgeable person on this planet on AI. So my question is, are we already in the age of strong AI, or are we still in the age of weak AI? And from your point of view, what is the difference between both of them?
Yeah, so I don't know that I would class myself as the most knowledgeable person in this field, but certainly, you know, there's a lot more knowledgeable people around, but that I rely on as well. But you know, I don't think we're to strong AI yet. I think we're still in the realm of weak AI. I think, you know, we really, and I think we will be for quite a while, you know, for the foreseeable future, for a few reasons. One is, you know, strong AI implies that AI will drive a lot of decision making on its own. I don't think we're quite ready for that as a society. I think, you know, the goal of AI really should not be to replace human intelligence, but to augment human intelligence and make sure humans are in the loop as we make decisions. I think as we start looking to the upcoming and inevitable regulations in the space, we need to really make sure that those regulations inform how we approach strong AI in the future, meaning that especially where AI impacts the health, wealth, and livelihood of humans, because those are the decisions that we want to make sure we have fair and explainable outcomes, so that people know how and why an AI came to a decision, and also so that they're not being discriminated against. And in fact, when done right, AI can help us minimize and even reduce or eliminate bias when we have these tools right. So that is inevitably introduced by humans, right? Humans are the source of bias, not the math. And so we need to make sure that we have a path to do that before we even think about strong AI.
Wow, what an answer! I just have to digest that. Wow. So, if I understand you right, Joseph Weizenbaum published his ELISA back, if I remember well, in 1972. So what you're saying, that 50 years after Joseph Weizenbaum published his code, we are still not applying strong AI. We're still in the process of weak AI. Did I get that right?
I would say so. Yeah. I mean, I think, the first iteration of AI was more than 70 years ago, right? In the 50s,
Yeah.
where it was really started to be developed. It wasn't until the last 5 or 10 years that we had the compute power to even think about really truly implementing and deploying AI. It wasn't until the last 2 or 3 years that we really had the data to do it at scale. And so while the knowledge has been there for multiple decades, some of it in fact developed at IBM in our research organization, the capability has not been around for a while, and I don't think that's unique to AI. We've seen that over and over again if we look back through history, where the knowledge to do things were developed, but the ability to implement them at scale was not realized until much later.
That's true. I switch off my cam. There are more questions, JGP.
Yeah, I have a question from Paul C's here. Can you offer any advice that would help us build AI-focused summer internship, stronger AI-focused internship?
So, I think IBM, Google, Microsoft, others all have internships in AI. And I think you probably just missed the window for applying for those. Most of them close mid-March. But I encourage you to, just Google AI, Google AI internships, and you'll see a whole swath of them come up across the board. Some of them would be focused on trustworthy AI, some not. Some would be focused on building AI solutions for the companies that you're working with or their customers, which, depending on the use case, may or may not incorporate the concepts of trustworthy AI. So the opportunities are out there, and they're actually quite numerous these days. So it's just a matter of finding them. Generally speaking, internship cycles open in November, December. And as I said, they start doing interviewing in February and March. So you just missed this year's cycle, but I would still look around for something, maybe some open still.
Yeah, Paul, if this answers your questions or not, just you can follow up. Erdogan, trusted AI requires explainable AI. Where is IBM AI on that front? Any product, services, any specific solutions demo in IBM Watson that we can check out?
Yeah, so a couple things. So one is, as a company, we are so committed to this and think it's so important that a lot of the tools and technologies we developed, the base of them are out there in the open source. And so they're all delivered under a Linux and through the Linux Foundation. And if you just Google IBM Fairness 360, you'll see a whole bunch of open source capabilities that are available. The base of those capabilities are available as open source projects. In terms of where we add value on top of those, absolutely, we have products that deliver value adds on top of that. We have Watson Studio, which has a trust component, which leverages some of those open source capabilities, plus significant value added capabilities. And I can provide some links that we can post afterwards to go see those. But certainly reach out to me if you want more details. Happy to talk about that.
Yeah, and Erdogan, we also had a few blog posts, and if you look at the previous edition of the Forecaster, we're mentioning a little bit about that part. From Michel Bakker, is IBM Enterprise Design Thinking for data and AI also available for business partners? That sounds like a very, very business partner question.
Absolutely, 100%. It is. It'll be up on our IBM Enterprise Design Thinking portal shortly. I'm not sure exactly the date, but it is going to be just like all the other design thinking assets. We make them public. But as a business partner, we can certainly connect you with someone internally to help you accelerate that journey.
Okay, questions from Purvi. This seems quite similar to what I am studying in an applied AI course right now. Just one question. Isn't social responsibility to consider as AI ethic principle in IBM?
So yeah, absolutely. So there are core principles that we have around AI. So one is, AI is, as I mentioned earlier, should be used to augment humans. We've also put some statements out there around types of AI that we do and don't support using, where we will and won't sell certain types of AI. But our core part of our social responsibility effort is focused on AI ethics and trustworthy AI and helping the world to implement those. So absolutely, AI and social responsibility is focused on how do we enable more ethical AI. And we have a whole research group out there on AI ethics led by Francesca Rossi. She's one of the foremost leaders in there, and she drives, combined with Christina Montgomery, who's our chief privacy officer, they drive the AI ethics board at IBM, which leads to a lot of these capabilities that we surface through our corporate social responsibility group.
Okay, anyone wants a question, you can also raise your hand, and if you want to ask your question, you can ask your question. You don't have to be shy. You can directly talk to Seth. I've been in his presence a couple of times, and I'm still alive. See, so okay, I see a question here. Ralph, go ahead.
It's incredible. I have to ask this. I'm about learning, and I really loved your slide about risk mitigation and assessment and auditing. So the question is, how do I test and test again the outcome of AI to not contain bias? Okay, we've been talking about the skin bias, about gender bias. I'm also talking about, you've been talking about the hiring process. So bias can also be in location. And how do you test this again and again?
Yeah, so you brought up a couple of key points within your question there. So one is, we're never going to eliminate all biases. We need to identify what biases we want to reduce or eliminate. There's AI is machine learning, which is the foundation of AI, is very good at discriminating A versus B. That's what it does. It identifies trends and it picks up this is happening, and maybe we can explain why. Now, when we look at kind of how we go about reducing or mitigating that bias and how we go about identifying it, there's a few ways we do that. So one, today we can do that algorithmically. So there are some algorithms that we use, or models that we use, to test for bias, and that we can say, given this specific bias, we know that we've controlled or protected this one class. So for instance, we want to make sure that we're not, in some cases, we're not discriminating against remote employees, to your point, Rolf, versus employees who are now in your location, or one gender or one ethnicity. And so that's one way to do it, is to algorithmically test and look at distributions and look at other factors that tell you that this model is not biased against that protected class, is what it's called. Now, there's this whole nother step of auditing. So how do you then go back and audit that model and prove that it does not have bias in it, that specific bias in it? We're working through that now today. There's a few ways you could do that. The ideal way is to have a data set that you know contains bias and you know doesn't contain the bias, and show that this model, doesn't pick up the bias in the data set, at a higher rate than in the non-biased data set. We're looking at doing that through creating synthetic data sets where we can introduce specific biases and we can eliminate those specific biases. Because if we step back to what I said earlier, I said something about this comes from humans. So math itself, so the math underlying AI is not inherently biased. The bias that math gets, it learns from the data. The database that data sits in is not inherently biased. Those data that sit in that database got the bias from the past decisions of humans. And so in order for us to build an AI algorithm that isn't biased and be able to test for it, we need to have data sets that we know are biased and that we know aren't biased. And these will need to be synthetically created to ultimately, drive the type of value and certifications that you're talking about.
So where you're saying eliminating dictators from my data set means that I will not have a model that will actually promote dictatorship. Did I understand that right?
So you want to be careful about eliminating data from a data set. So what I was saying is you algorithmically control the bias in the data. So you can actually reduce the bias in the data by tuning the hyperparameters or the features in your model such that they don't key on those attributes as much. So you apply a weight, maybe a negative weight, or you do some transformation of the data to help reduce that. So that's one step. If I was talking about creating data sets that have no bias, that's where you would use those to audit. So you would use those to test your model to prove that it doesn't pick up a bias. So for instance, in your case of dictatorship, you would create two data sets if you want to test for dictatorship. One that has bias towards dictators or against it, whichever one you want, and another that has no bias. And if your model is not biased, you would get the same result in both data sets.
Okay, got it. So the ideal situation would be to test AI with AI actually, and validate one thing against the other. Yeah.
Yeah. So we do that to a certain extent today, but we're not creating data sets that we can use to certify. So I'm talking more about how would I, in fact, audit that this model does not contain bias, when it's implemented or over time.
Great, thank you.
So I know where Ralph is going, is going to unit testing and comparing TDD in AI. So I have one. Okay, so you and me, we already talked a few times about your team and your cross-functional team and how diverse, not only from the traditional diversity we can see, like women, people of color, etc. But what was the biggest risk you take, and what was the most surprising result you got into having this very peculiar, I would say, individual, if I can say, bringing them in your team, and that you would not have expected, like something like you would almost like be an experiment? What was the most interesting profile?
Oh, the most interesting profile of a person I brought on the team?
Yeah.
Oh boy, that's there's more than one interesting profile, and so that's hard to say. So
okay, you get five.
Yeah. So one interesting profile is, we hired a couple of journalists who happened to have background in data visualization and a little bit of understanding of machine learning. And bringing on those journalists led to a whole change in thought process about how we tell stories around data. And in fact, that was my intent for bringing them in, but really driving the conversation with the data scientists around, when you get done with the output, how are you going to share this? And it's more than, hey, data journalists, come in at the end. It's really about integrating them from the beginning so that you start telling the story up front. So that's one profile, is people that had worked at 538, Al Jazeera, New York Times, became part of the team. Other interesting profiles were, actually, and maybe this was my bias because I'm from the space, but there were a surprising number of people from the biological sciences on the team, so from the life sciences on the team. And this may be surprising, maybe not surprising. Again, there is a little bit of a selection bias there, especially given a lot of people are hired from my network or my network's network, so it's inherently slanted there. But I think, as I said during my talk, this field that we think of started from the life sciences and from astrophysics, and so there is a depth of expertise there that probably isn't in other areas. And then, as part of the apprenticeship, we were able to bring in people from backgrounds where, their families had never gone to college, their families had never had professional jobs, and so, this was from their profile, it was, a unique experience, not just for them, but for their families. And some of these, young people wanted to go on and get advanced degrees, and their families were actually discouraging them. So they were discouraging them from using this as a launching point to get advanced degrees, because they were like, why would you even risk giving up this job to get an advanced degree when, in fact, they could get an advanced degree while they were doing this job? And so, I think it was interesting, and maybe, that's a unique profile for multiple aspects. But I think those three are really the most unique to the space.
How big is your team now? I mean, the elite
the data science elite team is probably close to 200 people now.
Okay, wow, pretty amazing. Questions from Otto, from Martin Otto. IBM console face recognition, which he thinks is a great decision. You've got to elaborate on that. Do we really have a chance of ethics standards in AI? Will explainable AI has a chance? We'll have a chance in times of Palantir, and there's even a cartridge for Palantir in Cloud Data Pack, in Cloud Pack for Data. So first, I don't even know what Palantir is. So if you do, I wouldn't mind a little bit of a.
So the decision was made at the AI ethics board, to, the board that I mentioned that was led by Francesca and Christina, that I'm a member of, to no longer sell pre-trained facial recognition models. So, that was, I agree, the right decision given where we are today from a technology perspective, as well as the way it can be misused, even if the facial recognition itself wasn't biased. So I think that was, I fully support. I was part of that decision. I fully support it. I think it's the right move. And you saw many other companies follow our lead in that space. I think, getting back to my reference to the AI regulation, so the EU regulation that's coming up, facial recognition is one of the things that's addressed there. Facial recognition has been addressed, especially for policing, by multiple states in the US. And then there's explainable AI capabilities inside of all of our AI software. And the part of Palantir that's in Cloud Pak for Data is something called Palantir Foundry, and or a version of Palantir Foundry. And that's really about building an ontology leveraging data. So it doesn't get into any of the things that you might be referring to there, but having explainable AI is what surfaced through Palantir and Cloud Pak for Data. And it's really providing a no-code, low-code interface for people to bring forward data and AI in actionable ways. And that's really the focus of Cloud Pak for Data with Palantir.
Okay. I hope, Martin, you're satisfied with your answer. Another one is, so talking about data, okay, everything is coming from data. How is it still so difficult in 2022 to get roughly clean data?
Well, it's about investment, right? I think companies need to, it costs money and time to do that. And there's, there's an investment that needs to be made by companies to create this data. Now, IBM and others are building tools to help accelerate that. So we actually have a lot of AI in our tooling to help you generate cleaner, higher quality data while ensuring privacy. There's efforts by multiple startups and IBM as well to move towards this concept of data observability, which, getting back to like application observability, how do you ensure the health and not measure that health of the data? One health metric is quality, and essentially creating SLAs for data. That's the ultimate goal here. But high quality, clean data doesn't happen on its own. It takes work, it takes money, and it takes tooling that helps make it happen faster, and then maintain it, right? Because entropy exists in the world, and if you don't maintain that data, it's going to lose its quality over time.
Yeah, I've heard that. Maybe even experienced it. Okay. So, Ralph, any other question from your end? Are you seeing anything in the chat?
Yes, I will use that chance to ask one more question. We've been talking a lot about bias and skin bias and gender bias. What do you think about, you talked about hiring and diversity, and that projects and teams that have a certain diversity are more profitable. What do you think about location-based payments?
What do you, so like different wages depending on what location you're at?
Yes.
Yeah, I mean, so that drives a lot of decisions about hiring, quite honestly. I think those are more business decisions. I think, I mean, bias creeps into everything, but we tend to, I think, there's some low wage areas of the world, some higher wage areas of the world. There's some low wage part of each country and higher wage parts of each country. So, I think that really comes down to a business decision. Now, there are laws in some states and some parts of the world about asking people's current salary when you're making hiring decisions, which can impact location. So, for instance, if I'm looking for a new job and where I live in Connecticut, it's against the law for a recruiter to ask me how much money I'm making, because it's shown that that propagates bias in previous hiring decisions, and in fact the salary should be driven by market forces and not by what someone is currently making. Now that is impacted by gender and ethnicity, but it's also impacted by location. So if I'm moving from, say, Bangalore, India to New York, how much I'm making in Bangalore is going to be significantly different than what I would need to make to live in New York. And so the decision of how much I make in New York should not at all be impacted by how much I'm making in Bangalore. And so I think, I'm not sure if that's what you're getting at, Ralph, but I think I created that answer.
Kind of. I would be interested to understand how, if we have a gender bias, we should pay females equal to males.
Mm-hmm.
Okay, if we have a location bias, I would say we should pay people from Bangalore the same as from New York.
Well, but the cost of living in those places is different, and what it takes to survive, and inflation rates are different in every part of the world.
But the skill is the same. We're not. You're judging about the cost of living, and putting arguments on the table that are subject to a certain situation. If I decide to live in New York, I pay more rent, of course. I get less in my pockets because I have to pay more rent, of course. But my skill is still the same, man.
Yeah. So socially, we don't consider where you live a protected class. And how we measure bias and what we think of as bias is driven significantly by what is socially considered a bias. Today, things like discrimination against age, against gender, against ethnicity, race, are protected classes. where you live is not a protected class. Now, whether you get paid the same as a woman or a person of color in a given location is protected, but not across location. So all other things being equal. So for instance, we still discriminate against by education. So someone with a PhD gets paid more with someone than someone with an associate's degree. That's, you know, that's not something that we said is discrimination. That's something that we say we can in fact have differentiation on. So I don't think society has quite gotten to the point where there's location is a form of you know, as a protected class.
Unfortunately, yeah. Still a way to go. Thanks for your answer. Yes.
It might evolve in the future, but even within the United States, people are not paid for the same job whether they're in California or in North Carolina. And not saying anything against North Carolina. So your next talk is in Cannes, the south of France.
Yeah.
Will it be broadcasted, or it's only it's a member only event?
I think I'm not sure if it's hybrid, but we can certainly find out.
Sure.
And it's going to be a talk focused on AI governance, which human-centered AI is part of it, but only a small part of it.
Any reading you would recommend to our audience? Any books that you've seen, read?
You know, a friend and a colleague of mine just published a new book, and I usually have it handy, but I don't. It's called by Kush Varney, and it's called Trustworthy Machine Learning. And I would highly recommend that one.
Okay, so we'll put that also in the forecaster in the next edition. Well, I think that our audience is very shy or very impressed or both, and I don't see any more questions. So guys, any questions before we let Seth go? Don't miss your chance. Okay, Seth, thank you very much. It was a pleasure, as almost usual. And I wish you a very nice and pleasant trip to the south of France and Paris, I've heard. So
yeah,
enjoy.
All right, thank you.
Bye.
Artificial intelligence.
Data. Analytics.
User group.
AIDAUG.
Join AIDAUG today.